All right, let's talk about parallel circuits now. So parallel circuits are one where the current has more than one path to follow. So current has more than one path. And remember that series circuits, they only had one path to follow, and the whole purpose behind a series circuit was to increase resistance so that we could slow the current down, okay? So a parallel circuit does just the opposite. A parallel circuit is going to decrease the resistance so that we can make the current go faster. So the current goes faster. So we increase current by decreasing resistance. So a circuit like that, a parallel circuit, looks like this. Okay. And I'll go ahead and we'll talk about the math, the basic math, and then we'll do an example like we did in the last video. Okay. So we've got resistor 1 and resistor 2 here. So in this case, when we want to figure out the total resistance, we actually use this math. So 1 plus R over 1 plus 1 plus R over 2, dot, 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 however many resistors you have, equals the inverse of the total resistance, okay? So when we get the answer here, we're either going to have to put it to -1, or if we have it as a fraction, we'll invert the fraction upside down, okay? So this is for resistance, okay? And then we have current. So what happens to the current? So because the current has more than one path to follow, it's going to split here and go into two different places. So the current at R1 and R2 is going to be different, but it's equivalent to the sum total of the current in the whole circuit. So I1 plus I2, as many circuits as I have, or sorry, as many resistors as I have, is equal to the total current. And then, of course, you know, we have a battery here, and each one of these actually has equal access to the battery, so there's no sharing. So in this case, the voltage at 1 is equal to the voltage at 2, which is equal to the voltage at 3, and so on and so forth. Okay, so let's do a very simple example. Okay, so I just kind of want to remind you from the series video, okay, and I'll just write this over here. For the series, I had two 3 ohm resistors, so when we had looking like this, okay, so you had a 3 ohm and a 3 ohm and a 9 volt. The current was 1.5 amps, okay, and then when we had a 3 and a 6, so a 3 ohm and a 6 ohm, the current, and again a 9 volt battery here, the current was 1 amp. So just so we can compare and see the difference, okay? So let's go ahead and look at a parallel circuit where we have two 3 ohm resistors parallel to one another. This time, 3 ohm, and we'll say still 9 volts, okay? So the first thing we always do with a circuit is to figure out the total resistance. So I'm going to take 1 over 3 plus 1 over 3. That's actually going to give me 2 thirds, right? But remember, it's the inverse, so we'd flip it upside down. So our total is going to be 3 halves, or 1.5. So the total resistance is 1.5 ohms. Okay, remember over here we had 3 plus 3 was 6. So we've decreased the resistance. Now let's figure out the total current, okay? So we're going to take the total voltage and divide it by the total resistance, and that'll give us the total current, and then we can figure out the current in each resistor. So the total would be 9 volts over 1.5 ohms, so that's going to give me a total of, what's 9 divided by 1.5? 6. Sorry, 6 amps. Okay? So we made the current go up. Here it was 1.5, now it's 6, right? So it's going to split, the current's going to split when it gets here or when it gets there, right? And so because we have the same resistors here, it's going to split evenly. So we're going to know that there's exactly you know, 3 amps of current going here and 3 amps of current going there. Let me just double check my math so this makes sense. Yeah, okay. So 3 amps would go here and 3 amps would go here. So let's look at that mathematically then to figure out, well, how much voltage is going to go here and here. Now, we know that the voltage should be the same, right? So voltage here and here, they have equal access to the battery. So V1 equals V2 equals V3. So let's go ahead and mathematically figure out the amount of current each here. We know it should be 3 each, but let's just figure it out. So we've got 9 volts, and we're going to divide it by the resistance at each individual resistor. So you take 9 volts divided by 3 ohms, and you get 3 amps, right? Which is what we guessed, okay? Now let's kind of do a little bit, one that's just a little bit more complicated. We're going to do the 3 and the 6 scenario, right? And we'll compare those. Okay, so now I have a circuit that is going to have 2 things in parallel. We'll have the 3 ohm here, and we'll have the 6 ohm here, and again 9 volts, right? So first step to any circuit is to figure out the total resistance. So 1/3 plus 1/6. So this is going to be 2/6, right? So I get 3/6, and then I'm going to flip it upside down because it's the reciprocal. And so you get 6/3, so the total resistance now will be 2 ohms. Okay? Now, let's figure out the total current. So 9 volts over 2 ohms, and now I have a current of 4.5 amps. Right? And we know that this gets 9 volts and this gets 9 volts, so let's figure out the current that goes through each. Now, if you think about it, like the current's going to come here and it's going to split this direction and this direction. And I'm sure you've heard the saying, follow the path of least resistance. Well, that just means that more electrical current is going to go towards the resistor that has less resistance, okay? So more is going to go this way than this way. And since it's like a 2-to-1 ratio, that's sort of what's going to happen here. You're going to get a 3 to 1.5 ratio, right? So 3 ohms will go here and 1.5 will go here. But let's just do it mathematically, okay? So again, each one gets equal access to the battery. So we're going to take 9 volts, divide it by 6 ohms, and it gives us a current of 1.5 amps that goes through this resistor. And then if I do 9 volts over 3 ohms, I get 3 amps through that resistor.